Hi Advanced Maths, we're doing 7.7 today, which is the intersection of lines. Now we've learned a lot about lines already, but what we're interested today is when do these lines intersect? Okay, now I'm just going to draw you two lines on the same Cartesian plane here. Alright, this is my first line. It's going to be, just looking at it, y equals x plus 1. There we go, that's a pretty easy one. And I'm going to draw another intersecting line which is going to go, let's say, down like that, pretty shallow. Okay, that's going to be y equals negative a half x plus 2. Okay, so those are my two lines. And noticing these two lines, we can see that they intersect here at that point. Now, it's obvious that they intersect, and if we were to draw this graph very perfectly, we would be able to actually find their intersection just by drawing them. However, algebraically is the best way to find out where their intersection is. Because they're straight lines, they intersect once. Straight lines intersect once with each other. Okay, that's once. Alright, now we're going to find out where they intersect. The way that we find out where they intersect is by simultaneous equations. Okay, now let's go make these into two simultaneous equations. So we've got the first one is y equals x plus 1. The second one is y equals negative a half x plus 2. What if I were to subtract these equations? 1 minus 2 gives me 0 equals 1.5 x minus 1, okay, which gives me 1 equals 1.5 x. Okay, which gives me 2 equals 3x, which gives me x equals 2/3. So they intersect at x equals 2/3, which makes sense. That's kind of where they look like they intersect there. Okay, now what about where the y intersect is? Okay, let's put that back into the original equation. Y equals 2/3 plus 1. Y equals 1 2/3. Okay, so that must be 1 there, and this must be 1 2/3. Well, that makes sense where they intersect. Okay, so once we found out that their intersection is 2/3 and 1 2/3, we have to test that these satisfy both this equation and this equation. They should, if we've done it right, we should already know that they satisfy both that equation and that equation. So let's just test. Okay, so we're going to go 1 2/3 equals 2/3 plus 1. Okay, that's definitely true. And 1 2/3 equals minus a half times by 2/3 plus 2. Okay, 1 2/3 equals negative 2/6, okay, which is the same as negative a third, plus 2, which is of course the same as 1 2/3. So these guys satisfy this point here. Now remember, straight lines only intersect once, so there's only going to be one answer, and so if this satisfies both this line and this line, then it must be the only intersecting line that's true. Okay, now sometimes we might get more than two lines that intersect, or the question might be talking about more than two lines that intersect. Say we have another line that intersects here. Okay, this line is y equals negative 2x, and there's going to be something else, but if I'm going to get this right, I can't just guess it, because there's only one line in the whole world that is going to satisfy this, you know, they have to satisfy this point, okay? Only one line is going to have this exact gradient of negative 2 and still satisfy this point here. So if I want to do the line with a gradient of negative 2 that satisfies that point, I'm going to have to use my point gradient formula. M equals y minus y1 over x minus x1. Now I know that my point y and my point x1 are going to have to be this point over here, because it's going to have to satisfy that point. And I've already written that it's minus 2x, so it's going to have to satisfy a gradient of negative 2. So let's say negative 2 equals y minus 1 2/3 over x minus 2/3. Okay, and then I'll be able to solve that and find out what the equation of this line is. I'll just very quickly solve that for you. Okay, so negative 2 outside of x minus 2 on 3 equals y minus 1 2/3. Sorry, this is going a little bit crazy here. Negative 2x positive 4/3 equals y minus 1 2/3 again. Okay, let's put everything over this side. We get negative 2x, which is what we want. Positive 4/3, positive 1 2/3 equals y. So y equals negative 2x plus whatever this is, which is going to be 4/3 plus 5/3, which equals 9/3, which equals 3. So this equation here is going to be y equals minus 2x plus 3. Lucky. That was actually what I was going to guess it was going to be, which is very good. So this line also passes through this point here. That means that these three lines, 1, 2, 3, these are all concurrent lines, which means they all pass through one particular point. Okay, the same particular point. That makes them concurrent lines. Okay, so if we want to find concurrent lines, we've got to make sure that we use the same point, because they all got to pass through that point. If we want them to pass through the same point, we can use our point gradient formula if we know the gradient we're looking for. In that case, I was looking for negative 2. Or if we know another point we think they're going to pass through, say we're going to find the one that passes through this point here, we can use our 2-point formula to find the line that also passes through there using this point and that point, okay? So that is what we're talking about with the intersection of lines. Simultaneous equations, and then find the ones that satisfy the point. Every line's going to satisfy that point. Okay, thank you.